In this section, the first question we're going to ask ourselves is, what is remote sensing? Well, remote sensing is the measurement or acquisition of information of some property of an object or phenomenon by a recording device that's not in physical or intimate contact with the object or phenomenon under study. That was a bit of a mouthful. Simply put, remote sensing can provide a cost-efficient and non-intrusive way to study local, regional, and even global sites. Remote sensing is performed using a variety of sensors mounted to platforms. The various sensors can collect data in multiple parts of the electromagnetic spectrum. Platforms include satellites, airplanes, drones, balloons, kites, cranes, birds, or any other means to take imagery from above. Historically, remote sensing relied on film to capture imagery from below. Modern remote sensing sensors, however, collect digital data on the surface of what's called a charged coupled device. CCDs collect pixel information, which are columns and rows of picture elements. Sensor resolution is going to come in a variety of forms. There's spatial resolution, which refers to the coarseness or fineness of a raster grid. Spectral resolution, which is the ability of a sensor to detect small differences in wavelength. Radiometric resolution, which is the sensitivity of a sensor to collect very slight differences in emitted or reflected energy. And temporal resolution, how often is data acquired for a location. After we explore the fundamentals of remote sensing, which includes platforms and sensors, we're next going to explore image information extraction. Image analysis, or image information extraction, is the act of examining images for the purpose of identifying and measuring objects and phenomena and judging their significance. Image interpretation is not an exact science, and in fact, interpretations tend to be probabilistic and not necessarily exact. Image classification is probably going to be one of the more powerful image extraction tools that we explore. Image classification can help us extract information from an image, including land use and landscape data. Information that can be used to identify or validate classification outcomes will be spectral signatures. Due to the nature of absorption and reflectance, individual surfaces will have different spectral signatures. And spectral signatures can help identify the feature compositions, including soil, vegetation, and water, of individual pixels by graphing spectral reflectance values of multiple bands for the pixel. Once we determine what a pixel looks like, we can actually compare pixels of the same area over different times to get a change analysis. There's a fair amount of information that we'll be covering over the next 2 weeks. From the acquisition of data, to the pre-processing of that data, to the information extraction of that data. A lot to cover, but very interesting and lots of fun. So let's get started.